we're going to integrate inverse secant of x. And to do it, we'll use both integration by parts and trigonometric substitution. So first we'll use integration by parts. We'll call this integral of a u dv. We have to make a choice for u. It has to be inverse secant of x, because if dv equals inverse secant, to go from dv to v, we must integrate. That's what we're trying to do in the first place. So dv has to be 1, so 1 dx. du, remember the derivative of inverse secant, it's 1 divided by x times the square root of x squared minus 1, and v will be x. So the integration by parts formula says the integral of u dv equals u times v, so that's x times inverse secant of x, minus the integral of v du, which is x divided by x times square root of x squared minus 1. Now here the x's cancel, and we have x times inverse secant of x minus the integral of 1 divided by the square root of x squared minus 1. So that is what we have left. We have to integrate 1 over the square root of x squared minus 1. And to do that, we'll be using trigonometric substitution. So I'm going to do that right over here. The integral of 1 divided by the square root of x squared minus 1. Since we have x squared minus 1 under the radical, the substitution is to let x be secant of theta. And then dx is equal to secant theta times tangent theta d theta. X squared minus 1 is secant squared theta minus 1, which is tangent squared theta. So replacing the x's with functions of theta, we have in the numerator dx, that is secant theta times tangent theta d theta. And in the denominator we have square root of x squared minus 1, which is now square root of tangent squared theta. So now we can rewrite this integral as secant theta tangent theta divided by tangent theta, which cancels in the numerator and denominator, and what we have left to evaluate is the integral of secant of theta. Now recall, this was done in an earlier video, the integral of secant of theta is the natural log of absolute value of secant theta plus tangent theta. Now we have to express this in terms of variable x. And our original substitution, x, we can write it x over 1 is secant of theta. If we draw a right triangle like this, and this is our angle theta, secant is the hypotenuse over the adjacent side, and using Pythagorean theorem, the opposite side must be the square root of x squared minus 1. And from here we see that tangent of theta, which is opposite over the adjacent, is square root of x squared minus 1. So we now can say that the integral of 1 divided by the square root of x squared minus 1 is equal to natural log of absolute value of secant theta, which is x, plus tangent theta, which is the square root of x squared minus 1. And now we can return to the original integral. We were integrating, trying to find antiderivative of inverse secant of x by using integration by parts. That was x times inverse secant of x minus the integral of 1 divided by the square root of x squared minus 1. And we now evaluated this integral, and our final answer, that is the antiderivative of inverse secant of x, is x times inverse secant of x minus the natural log of absolute value of x plus the square root of x squared minus 1, and we add c at the end. For more videos, visit www.mathprepvideos.com.